beginning, if you're watching this video, we've already discussed that this is the volume formula for a pyramid or a cone. And then this is the surface area formula for a pyramid or a cone. You guys can see it a little better here in the picture. I'll emphasize one more time. Do you see how the slant height, half the edge, and the edge of the lateral face makes a right triangle? And then we also have, I'll use a different color, the H height. Ooh, that color's not good. Let's do a different one. The H height, and then half this base length, so half of whatever this is, which turns out to be the apothem. So this would be H, and the apothem and the slant height also make a right triangle. And so that's the hard part for today, is figuring out what is H and what is L. All right. One thing I want you to add to your notes, super important, add this on your surface area formula. This formula only works for regular prisms and then cones. It only works for regular prisms or cones. That means your base shape has to be regular. Is a rectangle regular? No. So if it is a rectangular pyramid, you cannot use that formula. What you will have to do is just think about your net and find the area of all the shapes and add them all together. Okay, that's going to be the harder one. That is this one. We're going to save it towards the end, and if we have time, we'll go back and work one like this. That's harder. Yes, sir. Yes, I did. Please fix that. This should not be prisms. One more time. Fix it, please. Make sure you're listening. Go back to your notes. Only works for regular pyramids, which is our lesson today, not prisms, or cones. It always works for a cone because the cone is circular, and that circular is going to work out just fine. But for the pyramid, it has to be a regular base, a square, an equilateral triangle, a hexagon, a regular octagon. This has to be regular. All of my shapes are regular. So all of my shapes that you see would work with this formula. The only time it wouldn't work is if your base shape is not regular, like a rectangle. If it's a rectangular pyramid, you have to think about it as a net and find all your areas separately like you did in 8th grade or middle school sometime. So we'll come back to this one. It's a little harder. I want to show you some of the easier ones first, and then we'll work on it. So go ahead and flip to this example, and we're going to work it together. So find the volume and surface area of the regular hexagonal pyramid with a height equal to the apothem of the base. All right, guys. So we want to calculate volume and surface area. So start with your formulas. What's our volume formula today? 1/3 capital BH. Again, I'm going to encourage you to go over to the right and calculate your base area and your height separately. So come over here. Let's find the base area. What is our base shape? Hexagon. And remember, we talked about there's two ways to find the area of a hexagon. Do you prefer to do 1/2 apothem times perimeter or 6 equilateral triangles? Okay, I heard both. I heard 1/2 apothem times perimeter, and I heard 6 equilateral triangles. Since this says the height is equal to the apothem, that means we're going to have to find what? The apothem. And since we're going to have to find the apothem, I'm going to go ahead and work capital B today as 1/2 apothem times perimeter. If you don't want to do it that way, you don't have to. So just remember, you can do 6 equilateral triangles, okay? But I'm going to do 1/2 apothem times perimeter because it told us that our height was equal to our apothem. So we're going to need to know the apothem anyway. Is everybody okay with that? All right. So to find the apothem, let's start there. Where does my apothem go? From the center to the side. So not over to the vertex. That's the radius. It goes from the center to the side. This is your apothem. Okay? What else does it tell us? It's a regular hexagonal pyramid with a height equal to the apothem, and it tells us that this distance is 12. So if this whole thing's 12, what is this little distance right here? 6. So it's going to split that into 6 and 6. Okay, what is the next thing we need to find before we can figure out the apothem? Central angle. This all goes back to understand how in chapter 10, how to find the area of a hexagon, because you're going to have problems like this that may be octagons or heptagons or decagons. So the next thing we're going to do is find that central angle. Okay, how do we find the central angle? Good. 360 divided by 6. So what's our central angle? 60. Okay, so remember your central angle, though, is the big angle, the entire angle of this whole triangle, that equilateral triangle that you draw in from center to vertex, center to vertex. So if the whole angle is 60, that apothem splits that, so what is half of that angle? 30. And then I always just draw that triangle separately to make life a little easier to see it better. So I'm going to draw that right triangle separately on my paper. This is 30, this was 6, this was the apothem. And we want to find the length of the apothem. Easiest way to do that would be using your 30, 60, 90 triangle relationships. If this is 30, this angle is 60. What is always across from the 30? L. So we now know that L is 6. What is always across from the 60? L square roots of 3. So if L is 6, what does that make our apothem? 6 square roots of 3. So that means our apothem is 6 square roots of 3. So let's fill in what that means then over here in our formula. That means the area of the base is going to be 1/2 our apothem, which is 6 square roots of 3. We still need to find the perimeter. We haven't done that yet. Go back up here. What is that going to make our height then? If our height is equal to the apothem, our height is 6 square roots of 3. So now we know what our height is. So the only thing we need to find left is our perimeter. How do we calculate the perimeter? What are we finding the perimeter of? The base. The base is what shape? Hexagon. So how do we find the perimeter? Good. There's 6 sides, so it's 6 times the side length, and each side we said was 12. So what is 6 times 12? 72. Okay, so now we can plug that in to find the area of our base. So we know our perimeter is 72. It does not say to round, so again, we'll try to leave our answers exact. I'm going to tell you that I'm making this harder on you in the notes and on the homework than it will be on the test. Most of your problems on the test are going to be rounding problems, and so it's not going to be as difficult. But I'm trying to help you get ready for Algebra 2, and in Algebra 2, you're going to have to leave your answers in simplest radical form and practice those things. So the more we do that in the notes and on the homework, the better prepared for Algebra 2 you'll be. But then on the test, I'm not going to make you suffer if you make little mistakes like that. I'll let you round it and plug it in on your calculator, okay? So overall, your grade won't be hurt, but hopefully you'll be getting good at it before you go to Algebra 2. So what is half of 6? Because we're just going to multiply from left to right, right? But we're not going to plug the square root of 3 in. We're going to wait and save it for the end. So half of 6 is 3, and then we need to take 3 and multiply it by 72. So what is 3 times 72? 216. So the area of our base is 216 square roots of 3. We're going to leave that square root of 3 at the end. Try not to round. Questions so far? Okay, so now we know our area of our base. We know our height. We can just go plug it in for our volume. Yes, sir. Sure. Okay, so area of the base we said was 216 square roots of 3. The height was 6 square roots of 3. It was the same as our apothem. And now we're going to multiply all of this from left to right. So we're going to do 1/3 of 216. What is 216 divided by 3? 72. So we have 72 square roots of 3 times 6 square roots of 3. Now I'm going to let you go ahead and use your calculator. You can do it by hand if you want, but I think it'll be easier for you probably if you just type that into your calculator. Just be really careful when you type it in. So do 72 square roots of 3 times 6 square roots of 3. And what do you end up with? 1,296. Did somebody get a different answer? Okay, so can I see what you typed in, Visai? So do you see how your square root didn't stop and it went over everything at the top? Okay, so be careful with your square roots. You have to hit that little right arrow key to stop your square root. So 72 square roots of 3, stop that, times 6, and then the square root of 3. Is everybody else getting 1,296? Okay, so 1,296 what? Feet cubed. Okay, guys, this is the hard one. So questions? If you don't find this hard, then that's awesome. But if you're finding it hard, I need to know where I can explain it better to make sure you understand how we got the apothem, how we found the area of the base, how we plugged that in. Any questions on any of this over here? Okay, good. All right, so surface area will be easy now. Surface area will not be near as difficult as it would have been because we know a lot of the things we need. We're just going to have one extra thing we're going to have to find, which makes it just a little tougher. So surface area formula today is what? 1/2 PL plus B. So we already know the perimeter. What did we get for the perimeter? 72. Again, show your work over to the side and you'll find your answers really easily. What did we get for area of the base? 216 square roots of 3. What is the only thing we don't know right now? The lateral height or slant height, that L value. Okay, that's what we're going to have to find. And again, I told you that's the hardest part for today. So what we do know is we know our apothem length. And remember, your apothem goes from the center to the side. I could use it here in my picture. It's going to be harder for you to see, so I'm going to draw it from the center over to this side just so you can see it a little better. We know this distance is 6 square roots of 3. Agreed? Center to side. And we know the height of our pyramid. What did we find our height was? 6 square roots of 3. And so now what we're looking for is the slant height. So again, you're going to have to try to draw that picture. If you don't draw it, you won't see it, you'll get confused. So we know the slant height is what we're looking for. We know the apothem, we know the height, and that makes a right triangle. So now we're going to have to do Pythagorean theorem. I usually redraw that right triangle on my paper so I can see it better. 6 square roots of 3, 6 square roots of 3, and I'm looking for L. The height and the apothem are not always going to be the same. Is that what you're asking me? No, that's only because they told us in this problem that the height was equal to the apothem. So it's oftentimes they're not going to be the same. You'll just set up a right triangle and do Pythagorean theorem. It'll give, if you are looking for the slant height, it has to give you either the height or it would have to give you this edge length so that you could make a right triangle there. But you have to know one of the measurements along with the base edge or the apothem or you can't solve. Question, Dad? L squared of 2. So there's two ways you can actually work this. I don't know if you guys are following with what Thad is saying, but we can do Pythagorean theorem. I'm going to draw this on the whiteboard, so if you're watching the video, I'm just redrawing that triangle on the whiteboard where I have 6 square roots of 3, 6 square roots of 3, and L. So what Thad is noticing is that the legs are the same. And if it's isosceles and it's right, then that means these angles are what measures? 45 and 45. So if you don't want to do Pythagorean theorem, you could use your 45, 45, 90 relationships, which is much faster. So if we do it that way, we know, and I'm going to have to use a different letter since this is L because I don't want to confuse you. We normally say L, L, and L square roots of 2. So I'm going to say S, S, and S square roots of 2 just so you don't get confused by the L's. Is that okay? Okay, so you could do S is equal to 6 square roots of 3. And if that's the case, just substitute that in here. So we're going to have L equals 6 square roots of 3 times what? Square root of 2. You can type that in on your calculator, or you can do it by hand here. When you multiply with square roots, you multiply the numbers underneath. So that gives you 6 square roots of 6 for L. Okay, I also want to show you Pythagorean theorem because I'm afraid some of you might choose Pythagorean theorem and make a mistake. So if we did Pythagorean theorem, we should get 6 square roots of 6. So if you didn't and you just tried it, you've done something wrong. So if we do Pythagorean theorem, we should do 6 square roots of 3 squared plus 6 square roots of 3 squared equals L squared, right? Okay, take your calculator. What is 6 square roots of 3 squared? Make sure you put it in parentheses or you'll get the wrong answer. It should be 108. Make sure you're typing it in and you're getting 108 or you're going to make a mistake when you're on the test all by yourself. Is everybody getting 108? Just the big thing is that you put it in parentheses before you square it. So this is 108 plus 108 equals L squared. What's 108 plus 108? 216 equals L squared. So L is equal to the square root of 216. This is not your answer, so you don't have to simplify it for me. You could just leave it square root of 216. But if you did factor it down, you'll see that this actually factors into 36 times 6, which is 6 times 6 times 6, which means you have a pair of 6's that can come out front. And so you'll get 6 square roots of 6. Okay, or you can leave it square root of 216. Square root of 216 is the same as 6 square roots of 6. Okay, questions right now, one way or the other, how to find L. Okay, so now we're just going to plug everything we have into our problem. And on this one, we'll try to leave it exact, but if we need to, we'll just type it in. So we have 1/2. What was our perimeter again? 72. We found our slant height was 6 square roots of 6. Easiest way is at 45, 45, 90, but if you forget that, Pythagorean theorem works great. Plus, we have the area of the base. What was the area of the base? 216 square roots of 3. Kind of running out of room there. Now let's go ahead and simplify. What's half of 72? 36, and we want to go ahead and multiply 36 times 6. So what's 36 times 6? 216. So we have 216 square roots of 6 plus 216 square roots of 3. Can we add if we have a square root of 6 and a square root of 3? No, it's just like having an X and a Y. Those are different. You can't add them. So if we wanted to leave it exact, this would be our answer. What would be our units? Feet squared, because it's area. Again, I'm encouraging you to try to leave your answers exact because I'm trying to get you to practice working with those radicals. But if you are stressing out with the radical part and that's messing you up and you're having trouble, then go ahead, plug it in on your calculator and round it, and then you can check with me and see if your rounded answer is the same as my exact answer, okay? But I just want to try to challenge you and encourage you to try to leave it exact if it says to. If it says round, you're rounding. Okay, this is as hard as it's going to get. Okay, but I need to know, are you lost anywhere on finding the area of the base, the perimeter, or are you lost anywhere on trying to find the slant height, which is the tough part? Okay, and this is the hard part for today. So we're going to practice this a little bit more. So let's go ahead. So that the 216 square roots of 6 came from 1/2 perimeter times slant height. Half of the perimeter, which was 72, times the slant height, which we found to be 6 square roots of 6. Half of 72 is 36. 36 times 6 is 216. And then we brought down the square root of 6. Plus the area of the base. And the area of the base was 216 square roots of 3. Okay? All right, let's go to another one. We'll start with these hardest ones, and then we'll look at cones, and cones are so easy compared to these. I'm going to skip this one, so just ignore this problem. Keep going. I'm going to skip that one too. Okay, I'm going to come back to, I want to find another one I can do for you. Just a second. I want us to do one more before we do the cone. Actually, we'll go ahead and do the cone, and then we'll work the another problem at the end. Okay, so let's look at the cone, and this will probably help you with slant height a little bit more. So cone doesn't change. Volume doesn't change. Surface area doesn't change. They give you a different formula, but I'm not making you memorize different formulas. We'll just ignore that. So let's start with this one. Find the volume and surface area of a cone with a radius of 7 and a height of 15. Give your answers both in terms of pi and rounded to the nearest tenth. So first thing I would do is draw myself a picture of a cone. Let's label the things we know. It tells us the radius is 7. So draw your radius on your cone, label it 7. The height, when it talks about height, what letter is it talking about? What is height? Tate's right. What's height in our formula? H. What do we call the L? Slant height or lateral height, either word. So H, height, when they say height, they mean H. Height is going from your vertex perpendicular to your base. So they're giving you the height here is 15. What makes cones easier is they don't have an edge. They only have a height and a slant height. Whereas your pyramids have 3 measures. They have a height, they have an edge, and they have a slant height. So that gets a little bit more complicated. The other thing that makes the cone easy is it only has one distance here. It doesn't have an apothem and a radius. It just has a radius. Whereas your pyramids have a radius that goes over to the vertex, and they have an apothem, and that gets a little confusing. So again, if you need to, get your hands on an actual solid when you're working the problem and see if it helps. Okay, volume. What's our formula for today? 1/3 BH. So we're going to find the area of the base, and we're going to find the height. What's the height in the problem? 15. That's easy. What's the base shape? A circle. What's the area formula for a circle? Pi r squared. Be careful. We often confuse that with 2 pi r. What's the radius in the problem? 7. So we have pi times 7 squared, which is 49 pi. We're going to leave it in terms of pi first because it said give your answers in terms of pi and rounded. So now we just substitute these in. This goes in for area of the base. This goes in for the height. And the only difference from yesterday to today with the cylinder and the cone is that we're dividing it by 3 or multiplying it by 1/3. So we have 1/3 of 49 pi times a height of 15. Remember that you're going to do everything except the pi on your calculator. So what is 1/3 times 49 times 15? Or you can do 49 times 15 and then divide it by 3. Kirsten says 245. Somebody agree? Okay. So 245 what? Pi. And what are the units? Centimeters cubed because we're finding volume. Do you agree that was a lot easier than the pyramid? Okay, the pyramids are the hardest. We'll do another pyramid before we're done today, but does this make sense so far? Okay? So now we're going to go to surface area. What's our surface area formula for today? Pyramids or cones? 1/2 PL plus B. So we're doing half the perimeter times the slant height plus the area of the base. We already know the area of the base, but we don't know the perimeter and we don't know the slant height. So we're going to have to find those things. So let's start with perimeter. What's the base perimeter formula? 2 pi r because it's a circle. So our perimeter is technically our circumference. What's the radius? 7. So what does that give us for perimeter? 14 pi. Are we okay with perimeter? Questions? Okay, so now we need to find slant height. And again, that's the new part today. The cone's a little easier because it doesn't have an edge. So when we look at our picture of our cone, where is the slant height? On this picture, where is my slant height? Very good. Okay, so my slant height is the hypotenuse of that right triangle. That's made by the radius and the height. Are we all good with what slant height is on the cone? Okay, so now we just need to find our slant height, and this goes back to Pythagorean theorem. So we'll use that little right triangle, 15, 7, and L. So we have 15 squared plus 7 squared equals L squared. What is 15 squared? 225. What is 7 squared? And add those together to get L squared. So what is 225 plus 49? 274. Oops. Equals L squared. So that means our L is equal to the square root of 274. Okay, and we could make it much harder and try to simplify it all down. It may simplify. I'm not going to make it that hard for you on the test, I promise, to where the numbers are ugly and you have to simplify them all down. So for right now, we'll just leave it as the square root of 274. Plug that in. So we have 1/2. What was our perimeter again? 14 pi. Times our slant height, which was the square root of 274. Plus, what was the area of our base? 49 pi. And I'm going to stress again, show your work separate over to the side of your paper where you're finding B, you're finding height, you're finding perimeter, you're finding slant height, so I can see if you make a mistake somewhere to give you some partial credit. Okay, but label what you're doing. Don't just do a bunch of work over to the side. I'm not going to try to decide if that's your perimeter work, your area of your base work, your slant height work, so show your work and identify it. What is 1/2 of 14? 7. That is all we can really do without a calculator, right? Because we would have to multiply this on the calculator or multiply this on the calculator. So we're not going to round since it said leave it in terms of pi. So we will just put 7 pi square roots of 274 plus 49 pi. Or you could put 7 square roots of 274 pi if you want to. I don't usually do that because then it looks like the pi's under the square root. So I always put my numbers in front of the square root just so it doesn't look like they're under the square root. And we can't add those, would you agree? Okay, because this has a square root, this doesn't. So this would be our answer. What would be our units? Centimeters squared. And then it did say round to the nearest tenth on both of them. So we need to go back on our volume and on our surface area and round. So help me out on the volume or surface area first. What is 7 times pi times the square root of 274 plus 49 pi to the nearest tenth? 483.1. Okay. 517.6. This is to the nearest tenth. Okay, so it'd be 518.0. This looks good. Can I see, Gavin, what you typed in? You typed in the square root of 224 instead of 274. So look at what you have and maybe compare it, and then that'll help you see. All right, so I'm hearing that it was 517.95, and that 5 rounds the 9 up to a 10, which means this should be 518.0 centimeters squared. Is that correct? Okay, go back to the volume. What is 245 pi to the nearest tenth? Somebody agree with that? Okay, 769.7 centimeters cubed because it's volume. Questions? All right, let me look. I'm going to steal yours real quick, Matt, and see which ones I want to do next. So we're going to do the next cone question. This goes back to kind of what we did yesterday. Find the volume of a cone only, so it's just volume. Again, I would draw myself a picture. It's a volume of a cone, and what do they tell us about the cone? Tells us the base circumference, right? What does that mean, base circumference? The perimeter of what? The circle. So in our formulas, what letter is that giving me? P. The base circumference is the perimeter of your circle, which is the capital P, because that's the perimeter of the base. So they're telling us that capital P is 25 pi. And then what else are they telling us? The height is, read it carefully. Height is 2 inches more than twice the radius. Oh, that's wordy. So let's see if we can write that down. The height is 2 inches more than, so what are we going to do? We're going to add 2. 2 inches more than what? Twice the radius. So that means we're going to have 2r, and we're going to add 2 inches more. So 2r plus 2, or 2 plus 2r. Does that make sense? Okay, so let's see if we can find the volume, which is what it's asking us for. The volume is what formula? 1/3 area of the base times the height. All right, so if we want to find the area of the base, what is our formula for capital B? Pi r squared. So the only thing we need to know is what is the radius. If we can find the radius, we can find capital B. If we can find the radius, we can find the height. We need the radius. How are we going to find the radius? We need to work backwards. We're going to work backwards with what? The perimeter. What is my formula for perimeter of my base if this is a cone? 2 pi r. So we can say 2 pi r is equal to, what did they tell us it was equal to? 25 pi. So what are we going to do to solve for r? Divide by 2, and we can divide by 2 pi all at once. We want to get rid of the 2 pi, and the opposite of multiplication is division. So the 2 pi's cancel. On the left, we have r equals. On the right, the pi's cancel. And what is 25 divided by 2? 12.5. So now that we know r, we can find the height and the area of the base. And when you get to these problems, they look complicated. But as you draw yourself a picture and write your formulas down and decode the sentence, like height is 2 inches more than twice the radius, if you write that down, it starts to make more sense. So don't get to a hard one and just go, I have no idea. Draw yourself a picture, write your formulas down, start thinking, where can I figure something out, persevere, and worst case scenario, pick up your phone, call me, and I'll help you, okay? But don't give up. So plug your R in. Let's start with area of the base. We have pi times 12.5 squared. We're going to leave our answer in terms of pi since it did not say to round. So what is 12.5 squared? 156.25 pi. Okay, so now we have the area of our base, and we need to find our height. Our height was 2 times the radius plus 2. So 2 times 12.5 plus 2, which gives us 25 plus 2, which is 27. So now we know the height, we know the area of the base, so we can substitute it in and find our volume. So we have 1/3. The area of our base was 156.25 pi. And the height was 27. And again, it didn't say to round, so we're going to type everything in except what? Except pi. We're going to leave pi at the end. So on your calculator, you can type in 1/3 times 156.25 times 27, or you can do 156.25 times 27 and divide by 3. Whatever's easier for you. What do we get? Okay, Peyton says 1,406.25. Somebody agree? Okay, 1,406.25 pi. Can I look and see what you typed? Well, it'll go back. Did you not multiply? Yeah, is this what you did? You didn't multiply by 27. Yep. Okay, and units would be inches cubed. Okay, that's the big idea. Let's look at one more problem just to relate to what we did yesterday, and then we're going to try one more pyramid problem that's not in your notes. So if you look at the next problem, I'm going to skip it. Actually, is this the next one right here? Nope, never mind. Yeah, I'm going to skip this one, and I want you to go to this one. So it says the diameter and height of the cone are divided by 3. Describe the effect on the volume. Be careful here. They said divided by 3. So your answer can either be the volume is divided by blank, or what is dividing by 3 the same thing as? Multiplying by 1/3. So you could change the wording if you prefer so that it matches what we've been saying all along, and say that it's multiplying by 1/3. So you could look at it either way. I'll accept divided by or I'll accept multiplied by, but the number is going to change depending on what you do. So what did we say yesterday? If all dimensions are multiplied by A, what happens to the volume? It's multiplied by A cubed. Volume is A cubed, area is A squared. So if the diameter and the height are divided by 3, that means the radius is going to be divided by 3 because it's part of your diameter. So your radius is being divided by 3, your height's being divided by 3, and for volume of a cone, those are the only two measurements, your radius and your height. So all dimensions are being divided by 3, which means the volume is divided by what? 27. Because 3 cubed is 27. If you wrote it the other way and you said the volume is multiplied by, what would you say it was multiplied by? 1/27. So your choice, it's either divided by 27 or multiplied by 1/27. Questions on the shortcut? Those should be easy points. So if you're not understanding, please ask so I can explain it better. Okay, then if you look at the last question, and then I'm going to make up another pyramid problem. We may do one off your homework together. I'll look and see. But this is the last one that's in your notes, right? Okay, so this is back to our composite shapes. Basically what you have here is a cylinder and a cone and another cone, right? Stacked on top of each other. So it says find the volume and the surface area. We're not going to actually work it out, but let's just talk about it. So first thing is I want to know, based on the dimensions in the picture, are the two cones the exact same height and size? So take a minute and look at your measurements. Are they the same height so that they're the same size? We know they have the same circular base, right? Because they're sitting right on top of each other. But what we don't know is the height of this cone the same as the height of this cone? So I'm hearing a lot of no's. So this right here is how much? 40. When you see these little marks like this, that's not giving you the slanted distance. That's giving you the vertical distance. That's your height. So that's 40. What is this distance? 35. And so we're trying to figure out what this distance is right here. And they tell us that this whole thing to this point is 70. So if this is 35, how do we figure out what this is? 70 minus 35. So what's the height of this cone? 35. So only reason I wanted to point that out is to warn you to be careful, because you might look at that and just think, oh, I find the volume of one cone and multiply it by 2, which would work if they had the same height. But if they don't, then you have to find the volume of the cone, the volume of the cylinder, and the volume of the other cone and add them all together. Does that make sense? Okay. And they give you the length of the radius on both of them. They give you the height now on both of them, and you have the height of the cylinder. So this would be a very easy problem for volume. You don't have to find slant height. Everything would be pretty simple. Any questions about volume? Okay, let's talk surface area. If the cones are sitting on top of the cylinder, what parts are no longer a part of the surface area? The bases. Does everybody see that? So on the cone, I would not need the circular base anymore. On the cylinder, I wouldn't need the top circular base or the bottom circular base. So let's look at our formulas real quick. We're talking surface area. If I'm looking at the cylinder, I've got to switch back to yesterday's formulas. Be careful, which is pH plus 2B. What part of that formula do I not need since it's got cones sitting on top of it? The two bases. So instead of finding the whole surface area and then subtracting away the bases, it would probably be easier just to do pH. And that would give you this lateral area. Does that make sense? Okay. Look at the cone surface area. So what part of this formula do I not need since the cone's sitting on the cylinder? The base. So it'd be easier just to do the lateral area, 1/2 PL. Do you see how that would save you time? Okay. So you could find the total surface area of everything and then subtract away the circles, but you'd have to get rid of 2 circles here and 2 circles here, and that would just be more work. But you could. Any questions on the composite shape? Okay, let's do one more pyramid. I'm going to look at your homework and see if there's a good one on it to do, and we'll just do one off your homework together. And there is. So we're going to do one off the homework together. And that'll even limit I'll make you have less homework to do. Your homework is a worksheet again. If you did not have room, or if you do not have room to show your work neatly on here, do it on a separate sheet of paper. But please put your answers back on the worksheet. It will help me as far as saving time for grading. All right, so we can either do 3 or 4, but I'm going to say since we already did a hexagonal pyramid, maybe we should do a square pyramid. You guys vote. Would you rather do 3 together or 4 together? 3. All right. I like the idea of doing 3 better anyway because they don't give you the slant height. So let's do number 3 together. I'm going to put it up on the dot cam. And if you're watching the video, I am showing my work on the whiteboard. So if you need help on this, you'll need to come in and I can help you. Maybe I'm going to show it. Oh, helps if you turn your dot cam on. And so again, I want to emphasize, I would love for you to try to leave your answers exact, but if you're struggling and it doesn't say, I'll be lenient when I'm grading and I will give you credit if you're rounding, but try to leave them exact. If it says to round, then you need to round. So follow your directions, okay? So we're looking at number 3, and then we'll go back and talk about numbers 1 and 2 just like we did yesterday. So we'll actually do 3 problems together. Okay, so let's look at number 3. Square pyramid. Excuse me. We're trying to find the surface area and the volume. Let's start with volume. What's my formula today for a pyramid? One-third BH, or BH divided by 3. If you prefer to write it that way, feel free to. Okay, so we need to find the area of the base and we need to find the height. Looking at the picture, we should know what the height is. What is the height? The height is 5. Remember, height is that vertical distance from the vertex to the center of the base. So the height is 5. Area of the base. What is the shape of your base? A square. So what's the formula for area of a square? Side squared. What is the side length of our square? 4. So we have 4 squared, which is 16. So the volume is going to be pretty easy. We'll just plug that 16 in for B. We'll plug that 5 in for H, and then we'll divide by 3 or multiply by a third. So the volume is 1/3, 16 times 5. What do we get? .6 repeating, so I don't want you to write your answers that way. Write them as a fraction. What is .6 repeating? It's 2/3, and if you don't know that, go back, math, enter, change it to a fraction. And then remember, you can go to alpha y equals and change it to a mixed number if you want to. So I'll remind you one more time how to do that. I'm going to show you on my calculator because I want you to leave your answers as fractions unless it says to round, if we can. Sorry, my calculator wasn't opened up, so it takes it just a minute. Okay, so on your calculator, when you typed in, come on, why is it doing that? Oh. It wouldn't work yesterday either at the end. I wonder what I did to it. I don't know. Well, never mind. I'll go back to my .cam and use Matt's calculator since he so graciously said, sure, Miss Ashley, go ahead. So when you're looking at what Matt has typed in here, 1/3 16 times 5. Everybody with me? We're at this 26.6 repeating. Notice that he went to math and then number 1 changes it to a fraction. So he has this 80/3. To get it in mixed number form, you can go to alpha y equals, which is that top left gray button, and which one's going to take it from an improper fraction to a mixed number? Not 2. 2 is how to type in a mixed number, but which one changes from one to the other? 3. So you're going to choose number 3, which is going to take your answer and change it to a mixed number. And then look how nicely it gives you 26 2/3. Okay, so alpha y equals is where you can get that. So this is 26 2/3. And the units would be inches cubed. So try to leave your answers exact and in fraction form. If you don't have a graphing calculator and the fraction form part is difficult, let me know. But just do your best, okay? All right, surface area. What's our formula for surface area today for a cone or a pyramid? 1/2 PL plus B. All right. So We have the 1/2. We don't know the perimeter. We don't know the slant height, but we do know the area of the base. So we still need to find the perimeter. We need to find the slant height. And we know the area of the base was what? 16. So I'm just going to leave blanks there for perimeter and slant height until we find them. So let's find our perimeter. How do we find the perimeter of this base? 4 times the 4 side lengths, which are 4. So we have 4s, or you could do 4 plus 4 plus 4 plus 4. So we have 4 times 4 is what? 16. So perimeter is just the distance around your base. So the perimeter is 16. And it is just a coincidence that the perimeter of your base is the same as the area of your base. That will not always be the case. It's only because it was 4 units. And 4 times 4 is the same as 4 squared. Normally, that won't be the case. Okay? Slant height. This is where we have to be careful with our slant height. So remember, if you need to, grab a shape. I have most shapes up here with strings if you need them to try to see your slant height. But right now, they're giving us this H height, right? And we're looking for the slant height. So we've got to make a right triangle out of those 2 measurements. So that's what we're going to do. So I'm going to draw on this worksheet so maybe you can see it better. So we're going to draw in our slant height, which remember is the height of a triangular face. And then I'm going to connect it back to my H height to make a right triangle. So this is your L for slant height. You zoom in on that so you can see it better. What is this distance right here going to be? Half of that 4, which is 2. Okay, so now we're going to do Pythagorean theorem with that little right triangle. 2 is one leg, 5 is the other leg, and we're looking for L. So we have this right triangle, 2, 5, L. So Pythagorean theorem would be 5 squared plus 2 squared equals L squared. What's 5 squared? 25. What's 2 squared? Equals L squared. 25 plus 4? 29 equals L squared. So L is going to equal square root of 29. And 29 is prime, so that does not simplify. So we'll plug that in for our L over here into our surface area. And now let's go ahead and multiply and try to leave our answer exact since it didn't say to round. So what's half of 16? 8. We have the square root of 29 plus 16. Can we add the 8 and the 16? No, because you have 8 times the square root of 29, which is like a variable. You can't add 8x plus 16. So you can't add 8 squared to 29 plus 16. So this becomes your answer. And what are your units? Inches squared. And it didn't say round, right? Or did it? It did not say round, yes. So we're just going to leave it. Okay, if possible. Again, I want to stress, if you get to a problem on the worksheet and you're like, I don't know how to leave this exact, grab your calculator, round it. Having a rounded answer is better than no answer. And then I'll talk about it. If it was one that you should have been able to do, I'll explain that to you. If it's one that I expect you to be able to round, then that's fine and I'll give you full credit. Okay? Let's look at 1 and 2 real quick just to make sure you have those correct. Number 1, you should already be able to write the answer to. What is the surface area of a regular pyramid with a base area B and a slant height L? That's our formula from today. A regular pyramid with a base area B and a slant height L, the surface area is 1/2 PL plus B. Notice they said regular pyramid. If it's not regular, you would have to go back and find the area of every face separately. I'm not going to go back and do that first one we skipped, but that's one where you would have to do that. You would have to draw it as a net and find the area of every face separately. If we have time later, we'll work one like that, but not today. Okay, number 2 is the one we need to show some work on and figure out, just like yesterday. So they want us to write the surface area for a cone. So we're going to start with this formula. This is number 2. 1/2 PL plus B. The cone has a specific perimeter formula and a specific area of the base formula, whereas pyramids are going to change based on all your different bases. So what is our formula for the perimeter of a cone when we're dealing with a cone shape? How do you find the perimeter of the base? 2 pi r. So we're going to plug in 2 pi r for P. It said the slant height was called L, so we're going to leave it L. Plus, how do we find the area of the base of a cone? Pi r squared. And then we're just going to simplify the only thing we can simplify there, and that is what is 1/2 of 2. Half of 2 is 1. Half of 2 is just 1. And 1 times pi is just pi, so I'm just going to put pi r L plus pi r squared. And all we did was simplify half of 2. Half of 2 is 1. We don't need to put a 1 there. We can just leave it off. And that's the formula that you could memorize for surface area of a cone, but I am not going to ask you to do that. Is everybody clear? All right. So we did 1, 2, and 3. You've got about 15 minutes, not quite. So see how many more you can get done. This is due on Friday. And Friday's lesson's a little easier than today's. And if you need my help, please let me know so I can help you.